All right, so this will be a walkthrough of the latest Mixpeek feature called Taxonomies. And taxonomies are basically a way for you to define hierarchical structures and align those hierarchical structures to the assets that you ingest in the ingestion pipeline. And so what this enables you to do is kind of align various business terminology, nomenclature, categorization logic into your Mixpeek library and your Mixpeek collection. And so here's an example visual of what a taxonomy could look like. Here at the very top, we have the name of the taxonomy is Sports Training Library. And then within it, we have two children nodes. We have tennis training and we have golf training. And then within golf training, we have golf swing analysis and putting technique. And so this is what is really a hierarchy of nodes that all have different representations, right? So for this example, tennis training, we are pulling out two different embeddings from this node, and we're storing these nodes in our taxonomies store, right? And so we're saying, hey, use this video and this description and store them all as their own independent node. And so then what we can do is classify the assets that we've ingested and the features that we pull out from those assets. We can classify them using the taxonomies that we've defined here, right? Now, I know that's probably a little bit challenging to comprehend, so we'll just walk through a live example. So let's create a namespace, and this namespace is just going to be 3 embedding models. Keep in mind, in Mixpeek, namespace or embedding models are scoped to the namespace, and you could use your own embedding models, you could use ours. So here we just have 3 embedding models. We have a text embedding model, we have an image and text one, and then we have a video embedding model, right? And so we have this namespace, and now every request that we send has to have that namespace in the header, X namespace. All right, so what we'll do first is we'll just ingest a video into this text collection. And this video is just a very short clip of a cartoon Tyrannosaurus Rex yelling at a bunch of rabbits in a car. So let's go ahead and ingest that. And every asynchronous process in Mixpeek returns a task ID, and you can pull the status of that task on your own. And I would fully expect this to be finished by now. Still queued. Try again. Done. Okay, cool. So as you can see, we've pulled out the features from that video. And keep in mind, we stored it in the collection called test. Right. So now what we'll do is we'll create a brand new taxonomy, and we'll call this taxonomy animals. And we'll just put one node in the taxonomy just for simplicity's sake. And this one node, we are just calling it bunny. The name of the node is bunny. It's got its own description, and we are going to use an image of a bunny, and we're going to use the vertex multimodal embedding model. And we can use any number of embeddings on an individual node basis, similar to when you're ingesting assets, you can use any number of embeddings. So that's the beauty of this ability to do the multimodal search, multimodal classification, is we can use multiple embeddings to represent the same data, right? And so did we already create this taxonomy? Okay, it's creating now. And keep in mind, taxonomy names have to be unique in your namespace. Right, so we have our taxonomy called animals, and now what we can do is classify our features against that animal's taxonomy. So let's put assignment false here, and we have a confidence threshold of 0.25. It's actually quite low of a confidence threshold, and we just have one node, one taxonomy, and one asset in our collection, again, just purely for simplistic sake. And so we haven't appended any of the taxonomy nodes to our features because enabled is false, and append is obviously false as well. But what we can do is list our classifications from the animal's taxonomy. And this just allows us to kind of explore the results of the taxonomy classifications before actually assigning the nodes to our features. All right, so as we can see, we've got one match here. And again, we just have one node from one taxonomy and one asset, one video in our collection. And as we can see, it just barely exceeded the score threshold that we've supplied. And so let's say we like this, we're happy with the results. And so what we can do is then run this classification again, but set assignment to true. And so now it's actually going to append all of the matching nodes against all of the features that have a confidence threshold of 0.25 or higher. All right, and so now finally, what we can do is search within our features in the test collections, and then we can narrow down our search to the nodes that match this node name, in this case called bunny. So because in the features object, it is an array of nodes, we have to use this in operator here, but we can supply any number of the nodes that we want to use as filters. And in this case, we are doing a single query here. And again, we can supply any number of query objects in this queries array. And in this one single query, we're just searching for T-Rex roaring using the vertex multimodal embedding model. And then we're just supplying a filter to say, hey, only return results where the features contain a node called bunny, right? Cool. So we got our results. And as we can see, we've got just one result here because we just have one feature in our collection. And that one feature has this node classification. And the node classifications that we're returning are node IDs. just because they are idempotent. So you can change the names of your nodes in the taxonomy endpoint, but the actual node IDs that are appending to each feature, they will not change. So they're fully idempotent. And so that is a run through of the Mixpeek taxonomy feature. We defined a taxonomy, we classified our taxonomy against the features in our collection, and then we did a search across our features that contain nodes from that taxonomy. Thank you for listening, and let me know if you have any questions. Thanks.